Welcome, class, to Data Manipulation and Management and SQL 101. This is the spring 2025 class, and this is class 7, Advanced Database Functions. So this is the last full class or full lecture of this class, and what this class covers is some of the advanced database functions that are across the majority of relational databases. So these advanced database functions, they'll vary quite a bit depending on the database management system you have, whether it's MySQL or Microsoft SQL Server or Oracle or any of those flavors, Postgres, so forth. But they're really pretty common across all of them, and they're valuable to know as a data analyst, especially when you're on the job and maybe an advanced data analyst or data scientist or architect has created some of these things, and you'll be able to do some of it yourself. Right. So the objectives for tonight is to cover these advanced database features. So the first section of this is going to be temporary tables and common table expressions. So as a data analyst, I use temporary tables a lot. It's like in class 3 where we created our own tables, but this allows, these are temporary tables, so they aren't persistent. As far as when I've talked about data that persists in the database, it only exists while you're logged into the server. And then once you log out, these tables go away. And you say, well, what's the difference between creating a regular table and a temporary table then? Is that we'll see with stored procedures, oftentimes you can create them as a bunch of intermediary steps where you can create all these temporary tables out of queries, and then you can combine them into one big result set at the end. I think it personally, and then it's easy to check the data in each one to have, you have exactly the data that you want. And that would be without having to create permanent tables in the database. So they can often be somewhat easier to create, but you do it in a similar way that you do with tables. Lots of people also use common table expressions. I do it occasionally. We'll see this is where you can nest queries. So you could have one query, and then the second query uses the first query, and the third query uses the second query. And if that's a little confusing, you'll see how it works. It can really be useful for those type of things where you have like nested subqueries and you just want to do it one piece at a time. We'll also see we'll compare standard versus procedural SQL. So standard SQL is what we've done throughout the entire class. This is a common language used to communicate with the relational database. They tell the database what information you need from tables or views or other database objects. So it's how the database will interprets your code and then gets you the results that you're writing in code. And those are just, you're doing that query by query. You're writing a single query, you get the result. You write another query, you get that result. What procedural SQL will do, and almost all the relational databases have some type of procedural SQL functionality. It allows you to combine SQL along with procedural features of programming languages. So what that means is that you can more or less create a function in the database like you would in Python. You can have parameters that you send to it that will return a result set to you or a single value. And these can be, like I talk about temporary tables, why they're useful, is that you can put multiple steps within your procedural SQL. So it doesn't have to be one query. You could have one query, a second query, and a third query. And then you could have some if-then logic that you put into it. It's more like a programming language. I've seen it as really useful as from a perspective of like loading a data warehouse, is that they'll have a number of like 7 steps to take the data from like some landing area and load it, all the transformations that loaded into your OLAP data model, like we talked about in the last class. Or you could have like a number of checks and so forth. I've also seen complicated reports put into procedural SQL. So if it's something that's multi-step and it's a little complicated to put into a view, you can also put it into procedural SQL and run the stored procedure and be able to get a result set that way. So stored procedures, I use those quite a bit, whether it's creating my own process or stored procedure or running existing procedures that other people have built. Maybe they're like systems administrators. They build a number of stored procedures for you that you can run to get data. That's really common. Or sometimes you have complicated logic and you put it in there and then you hand it off to a systems person or data warehousing person, and then they integrate that data. And then last, we dive deeper, more into the procedural SQL techniques. So there are 3 different types of procedural SQL that you can do. I talked about stored procedures, but there are also triggers and functions. So functions are like the functions that we learned about early on in the class. You can have scalar or aggregate functions. A lot of those are like standard or specific to a relational database. So what procedural SQL can do is allow you to create your own functions. And we'll see that in action. I've had that be useful in times where I needed to do some statistical calculation that didn't exist as a function in the relational database. Maybe I'm like detecting outliers in a series of values and doing some standard deviation or some complicated calculation that I just wanted to return in the database query. I create a function for that. And then triggers. So triggers are just slightly different in the sense that triggers update, delete, or insert values based on actions that happen on a table. So those actions are also inserts, updates, and deletes. So basically your table will detect that a new action happened. And then you'll say before it or during or after that action, what else do I want to update in that table? I briefly mentioned it in another lecture as like maybe someone, one field, they changed their last name to a new one, and maybe you trigger a field that's called maiden name, and then you put the maiden name in there, and then you update their last name with their current last name. So there are things that you can do there as far as like triggering another update or delete or insert action based on action that's happening in the table. I don't use those very much. Usually that's like really when you're doing things in transactional tables, potentially where you update multiple values at the same time, and that one field depends on another field. So if something happens to that one field, then you update the other one accordingly instead of, and then you could kind of, with a trigger, you can script that. And we'll see how that works. And then for all of these techniques, we'll see the structure of it, how you structure each one of these types of procedures, whether it's stored procedures, triggers, or functions, the syntax, so the way you have to type it in, like we covered at the beginning of the class with the standard SQL, and then variable declaration. So one of the really helpful things you can do with these is set variables like you do in a programming language. You can do that at the beginning of these procedures, and they can help you out with various calculations. Then you could use them in calculations within the database. So I would say I just started teaching this the last couple of classes. It's very much different than standard SQL, but it is useful. You can include standard SQL within procedural SQL, and it's good to at least cover it with some initial knowledge, knowing that it exists, and at high likelihood that you would use some of it as a data analyst also, working within relational databases. Okay, so that's really the goal of tonight, is to get everyone familiar with it. We'll have simple examples for the class project. Try to make these not too difficult or anything, and have people struggle or spend too much time on it. Okay. All right. So temporary tables and common table expressions. So temporary tables and common table expressions both define temporary result sets that can be referenced in query syntax. So our regular SQL that we do, those produce result sets from writing the query. So when I talk result sets, that's what appears at the bottom of your MySQL workbench when you run a query. So you run a query. I'll just go ahead and run one real quick. You get these results, a result set. So both temporary tables and CTEs both define temporary result sets that you can either reuse as far as temporary tables are concerned in multiple places, like you would if you build a table, or a common table expression where you can do nested queries. So some of the key features of these are that temporary tables exist for the duration of the session. I'd mentioned that, so it only lasts as long as you are logged into the database. They disappear after that. So they're like perfect for short-term analysis. If you're pulling some data in a database, you can load it into a temporary table and then manipulate it a bunch of different ways. So really good for multiple step processes, or if you're reusing that data set for multiple purposes during your current session that you're logged into the database. So CTEs are a little bit different. They only last as long as the query does, just like with the regular SQL that we've done. So once you run the query and it's done executing, it produces a result set and that's it. Whereas temporary table stays around after that. But this can also be valuable too, because you can see it can simplify subqueries and joins and allow more complex operations. So if you have a subquery, like if you have a from, you could put a subquery here, but you can also do it as a common table expression with this syntax. You do a with, and then you give it an alias as this table, this query. So really what this is doing is producing a result set named CTE as you run this query, and then if you call this query 1 and query 2, you can use that result in query 2, that result set, and then join it with another table or whatever else you need to do. This, in a way, it's kind of similar to a view. That's why I use views a lot. It's because you could create the view and then use the view. But this becomes really handy if you have a bunch of nested queries. You could actually make this as long as you want. You could have CTE1 that's used by CTE2, that's used by CTE3, and then your last one is like you use CTE3 in your main query. And then you can nest as many of those as you want. And that can be more, it can be more efficient than writing queries and like having all of those executed. Oftentimes it's like a performance consideration when I go with a CTE versus like a temporary table or a view. So someone who's like a database administrator or like an advanced data analyst, if you're having trouble with how long a query is taking, you could potentially rearrange it as a common table expression. And then some people just like it in general. They just prefer to write the original query and then write it in the second query. So it's really up to you as a preference. I like temporary tables personally because then I could query them and see the result. And then I get to keep that result set that I can use other places. But you could also run this piece by piece also. So no right or wrong answers, just 2 ways that you could put temporary results in there to make your regular queries, SQL queries, a little bit easier, especially if they have multiple steps. All right. So I restarted my computer so we could run some of these examples. So I created 2 ways of doing the exact same thing with the Sequila database. So this task is to find the top 5 Sequila customers by rental count and then retrieve their names. And you can notice the syntax difference. One, you say create temporary table, and it's like a regular table. You can create that from a query. You almost always create it from a query. You could insert values into it also. But I like to do like some subset of the data. Maybe you have some rules in there. Just put that in the table and reuse it, which is kind of what they do here. So they do with the regular SQL query, they do customer ID and count. And since this is a column function, you group by customer ID. You order them by the number of rentals they have, and you take the top 5. So similar to query that we've seen before to get your top number of countries or number of customers or so forth. But we store all of that in a table in step 1. And then we go and get more information about those customers. So we get the customer IDs of those customers, join it with the customer table to be able to get their information. And then the third step, oftentimes you can drop a temporary table just like you do a regular table. So whenever you're done using it, you can drop it. Or whenever you log out of the database, you should also drop the temporary table. It's not a bad idea at the end to just drop it anyway. Some database administrators may find it annoying if you leave a bunch of temporary tables or memory there. They have to free up, but that's a wrestling match with your database administrator, I think. But that's kind of a sidebar. You can keep them as long as they're useful, as long as you're using it in other queries. You don't really see this appear in like your tables or anything. It's just behind the scenes. You won't see your temporary table here. These are regular tables. You just know that in your given session that you have a temporary table named that, and then you can use it in multiple places. Right. So I kind of like this approach because it breaks it down. It really I feel like it breaks the problem down into smaller steps. If you have a big query, which is like what I really try to do if I'm like doing a bunch of joins or subqueries and trying to put it all together, like breaking the problem down into smaller parts. I mean, CTE also does that too. So this is how you take the CTE approach. So you would do a with, and then your result set name as that query that we did there. So now this is a result set with those customer IDs that have the top five customer IDs by rental count. And then you could take that CTE and use it in your regular query. So you see it's almost the same thing. You don't have to create a table here or anything, but you can use it within your query. So nearly identical approaches. This, like I said, the CTE is probably the most useful when you have multiple nested CTEs, when you're doing top customers, and maybe you do some other manipulation or summary to those customers. Maybe you get the number of sales using this, and then the number of sales you include in the final result. So you'd have top customers 1, top customers 2, and then use it at the end. You're doing multiple summaries. And it's useful to do it that, just break it down and do it that way. And sometimes it can work a little bit faster depending on what you're doing. I don't really have that many tips on which one would be faster. I feel like temporary tables can be, but sometimes it's just trying different things in your query and rearranging it, or trying different approaches and see which one works the best. That's how I do it. Okay. So that's temporary tables and CTEs. We could go ahead and run this too. And one thing I want to do, I haven't put it in the PowerPoint SQL yet, as I was just working on these examples today, but I would like to put these in there and then share these with the class. So I'll just put it in my downloads folder for now. So let's go ahead and run these 2 examples just for everyone to see. I need to open where I have these queries. Over here. Be just one quick second. And I forgot to mention on the syntax on this previous table. So you can see, like we saw, is print or create temporary table. And then you can define it this way and then have your query underneath of it. So you can define the data types within it. But this one was like creating it from a query like we'd seen before, like how you copy tables to your own schema. So let me go ahead and get these examples for you. Okay. Ooh. Okay. Let me try to copy that one more time. Okay. Temporary tables approach. So you can see we're going to create this table just straight from a query. And with some of these, you will also have to list not just the table, but you'll say sequila.rental. You do a temporary table, create this in your own schema by selecting those fields from the Sequila rental table. So let's go ahead and just see that query. So I can hit that. You see the top 5 customer IDs by rental count. So now if you run this whole part, create temporary table was successful. Even just to check, I'd like to, you can query the temporary table. That's what I like about temporary tables, is that you can just query them to make sure, it's easy to query them to make sure you've loaded the right results. Call this a check. So you see we have that same result in a table now. And then we could use that temporary table. I'm going to look at something real quick. Yeah, the temporary table does not show up in your schema because it's still temporary. But you can refer to it by your schema name and temporary table name. And then I joined the Sequila.customer table on it. And now you have the first and last names for those customers. Like I said, really big fan of doing this in smaller parts, especially for complicated queries. And then our last step, cleanup, we can drop the table. And then it no longer exists. And if you try to run that query, it says that that table doesn't exist. Right, and then we can also do the CTE approach. Okay. So in a way, you can still run this part by part. You could run this inner query. And then you would have to do Sequila.rental. I'm not sure if you have to put a schema name on that. We'll find out here in a second. I think not, because I think this is just an alias for a result set that we're about to see. Okay. So we have the customer ID, top 5 customer IDs with rental counts. And with this, you have to run it as a whole. You can't run it as one part. So it's like all or nothing with the CTEs. So let's go ahead and just run this whole CTE. Yep, and I was right. So with the top customers, you don't have to have a schema name, because all it's producing is a result set that you're reusing in that same query. So it's not producing anything permanent or temporary or anything like that. It's just holding this result set and then using it in the final query. Then I can join that by the table in the Sequila database to get the same result. So 2 ways of accomplishing the same thing. It's just 2 different approaches. And neither are right, or using one over the other is not really right or wrong, I think. Just it's your preferred approach and whatever works the best from an efficiency standpoint, or however you're bringing the data together for analysis, or just personal preference. So now you know 2 things that exist that will help you pull data from a table, particularly, or relational database tables, particularly in multiple steps, without necessarily the need for subqueries. Subqueries can also be valuable too, especially if instead of in a from, you're doing a where, and you do a subquery in a where to return, so like a list of customers that you want to filter. So subqueries are still useful in different spots. So it's just choosing the best tool for whatever you do and what your preference is. Okay. So we'll try to get through the lecture here. I'll probably get through it in another 20 minutes or so. So we have standard versus procedural SQL. We call the standard SQL is what we'd learned throughout the class. It's the common language used to communicate with databases, for you to communicate what you need to the database as far as what table, what fields, how to summarize the data, how to order data, so forth. It's non-procedural. So what that means is that the language generates logic to navigate the database based on the written query. So you aren't creating all this logic. The database interpreter and compiler already has that logic. You're just using the SQL programming language to communicate, and then the interpreter has all that logic behind the scenes to get what you need from those tables. So instead of having to write this huge program, you could write SQL. You could write SQL statements instead. And very effective at tabular data and joining tables and relationships and so forth. So what procedural SQL is, it's an extension of the standard SQL that enables developers to include programming constructs like procedures, functions, and triggers. So these statements are usually like, it's when the Regis standard SQL, it's difficult to do or maybe impossible to do in a standard SQL query, that these procedural SQL provides a capacity to start to be able to create your own logic through procedures, create your own functions and actions on the database with triggers. They're generally executed in a scripted fashion. They're generally multiple statements. It's processed in order that each statement is written from top to bottom. So you can have multiple queries within this result set, and it'll just execute them one by one. And this is where temporary tables are useful, because you can do one temporary table, use that in your second step, use that in your third step, and so forth to produce your final result set. And you see with a procedure like this, this is a stored procedure example. You name it like a function, like you would in Python. So you create this stored procedure called get all products. You could have parameters here, which we'll see. Maybe it's a product ID, and then you could select this. This query would return you all the information for a certain product ID. So usually it's like some type of specialized logic that's either hard or impossible to do in a single query or with standard SQL. So we'll go ahead and not quite see examples yet. We'll talk about the structure and syntax first. So the structure of these procedural SQL, it's pretty similar across all the relational database management systems, with just slight variations, but they all typically start with declaration statements, like you're declaring variables in a programming language, and then you begin and end the execution of the program, and then you have some exceptions. So if something goes wrong with it, you could tell the database interpreter to warn the user and give them an error of whatever happened that was wrong. So really similar to a procedural programming language like Python. So the declare statement, so where variables and constants can be declared and store data temporarily. We'll see this shortly, but you could load a variable with the current date so that you could do a date calculation, like the difference between the shipping date and the current date. And then that becomes a dynamic variable, because every time you run it, you'll get the current date and calculate everything from that. You can also do constants. You could just set a variable equal to 1 or 2 or a string or something like that. That can be particularly useful if you use it in multiple steps or queries inside a procedure. We'll see an example of that. So execution, after you declare the variables, this is optional. You don't necessarily have to declare any variables, but everyone will have a beginning and end. That's common across relational database systems. So this is mandatory. And this is where the programming logic is written. It supports DML, the data manipulation language, so inserts, updates, and everything. Data definition language, so you can create tables, drop and create tables inside of this. And SQL's built-in functions. So all my SQL functions will work in here too. Then the last part's exceptions. So in most programming languages, you have the capability to handle exceptions. So if an error happens, it's not vague. You can create your own error message to say specifically what happened. MySQL has the capability to do that. You can do custom exceptions, or they have a bunch of existing exceptions that you could throw to the user for whatever error happened. So, excuse me. One good resource is this introduction, Geeks for Geeks. If you want to learn more about the basics, we're covering here, but you can see the differences between the regular SQL and P-SQL, the structure, different identifiers that you can use there, and variables you can declare. And they don't have any exceptions in here. Begin. See, they have the declare, some of these declare statements. You can declare these variables. And do they have any examples in here? They do not, but that provides an overview. Oh, one of the good things is that this site has, like, if you've been asked in other classes, what would you be asked on an interview? So there are interview questions in here, even P-SQL interview questions if you want to test some of your knowledge of what you learned in this class, or about P-SQL and so forth. Just clicking on some interview questions. And they have the cheat sheet here and everything, and different flavors of, or the different flavors of relational databases, like MySQL or Microsoft SQL or Postgres, and even a NoSQL database, MongoDB. So there are a bunch of SQL questions in here. So if you're questioning what you learned in the class, you could go through this and test yourself. And pretty good questions that you may very well be asked during a data analyst job interview. All right, so slight detour, but remember those were part of this Geeks for Geeks website. Okay. Sorry. All right. So the SQL routines, we'll talk about define SQL routines and what we mean by that. So SQL routines are either stored procedures or functions defined and stored in a database. So routines are like functions that you can define, or a routine in a programming language, like a series of steps in code. So essentially, it's a block of SQL code that can be called and executed from within other SQL statements or programs. So what's good is that you can use this within SQL by, like, this is stored procedure example. You can create this stored procedure. This one is just an example of, say you're updating an employee's salary and you have this employees table. You create these variables. You set at the beginning, you declare your variables optionally, but you want to do this, if you wanted to do this as parameters, this is how you would do it. And then you do it as, and then beginning, end, and then put your logic in there So this is an update statement on the table employees, where salary is equal to salary plus increased amount, and where the name is the employee name that you put into the procedure. So then you have this command exec where you can execute a stored procedure, and then update salary is the name of the procedure or function, and then your parameters that you define through these declared variables. So this would go into this table. It'd read in John Smith. It'd read in 1,000. So it'd update employees where salary is equal to salary plus 1,000, where name is equal to John Smith. So what's good about this, especially with like repeatable processes, and if you want to do it a bunch of different ways or create a bunch of different result sets. So I've seen these created as reports. You put a report in a stored procedure, and then you provide an interface with some values that the user can enter in, and those go into as parameters in a stored procedure to get whatever result is entered in that interface. So oftentimes it's like a date range, and then maybe like a customer or a location or something like that. It gives them their own dynamic reporting tool that they can use. And that is used like inside of like an application or some interface. So very nice to be able to do that. It can be in a program. And then if you create a function, we'll see in a second, you can use that function inside of a regular SQL query. So commonly, these routines are used to perform operations on a database like insert, read, update, delete. So if you've heard of CRUD operations, those are them. So it's create, read, update, and delete. Something that relational databases do very well, especially on tabular data. They accept inputs and they return some type of output. So this will return either a result set or a single value, the stored procedures, and then the functions will return a single value, whether it's a scalar function that you create or it's a summarized function that you create. So you'd run the summary function potentially on the entire column. It'd return a value, or as a scalar function, it'll return value by value if you create your own function. Right. Let me know if you have any questions along the way, of course. So diving deeper into stored procedures. So stored procedure is a collection of SQL statements that are saved in a database for repeated use, especially those that have multiple steps, very repeatable. I gave the data warehouse example earlier. That's when you have data and there's just like a set number of loads and extracts and transformations that you have to go through to that final step. That's where you may use that. Or with a report with those parameters, and you could write a SQL query to make that dynamic. You can do some if then while logic in there and some error handling between the beginning and end. All right. So these are valuable for enforcing business rules. We've talked about implementing complex transactions or logic and then saving it for future use, returning as a result set or value. So it's dynamic and helps you make complex logic into less, or like abstracts it into like this function. And then also enforces business rules. So imagine we talked about creating a view where maybe you created a bunch of groupings or you did some cleaning of data. This could potentially be the same thing where you did multiple cleaning steps. and you had multiple temp tables. And those are all the business rules that you want to enforce or keep, where you created some groupings or special logic for some system event or some outlet or some, what do they call those, edge cases that happen rarely. Those seem to have a lot of rules created for them to try to detect those type of things. Like in a supply chain, if some item is suddenly sold for $1 when it's supposed to be $100, like detect that and make sure it doesn't get sold. Maybe you write a bunch of that logic in there, and you run the transaction against the stored procedure to make sure that the conditions are met. If the conditions are met, maybe you throw some type of error, or do some type of error or something. All right, so that might be a business rule, enforcing business rules. You may have a bunch of them wrote into stored procedures. So we're going to do an example here. We're going to get the films rented by customers using the customer ID field as a parameter. This is from the Sequila database. And then you can see you can use this by using this call get customer rentals. I think before we also saw that you can use exec. So let's go ahead and get the code and give this a try. Okay. So if we have the stored procedure example, delimiter is not too, I guess the delimiter, what it will do is delimit the end of the stored procedure, but I don't believe it's that important in this case, because you have to start and end the delimiter also. So let's just see if we do that. Sometimes if you have complicated logic, it would help to have a delimiter at the start and the end to indicate where the code starts and then where it ends. And then you delimit it at the end. Okay. And maybe we will actually have to do that. It did give me an error, so there must be something in there that it likes having the delimiter for. Let's go ahead and run that with the delimiter. Okay, that looked like it created successfully. Maybe it has to do with this. It has to do with the semicolon. Not entirely sure, but the delimiter helped it out in that case. After you create it, it does go into your schema as does go in there as a stored procedure object. And of course, I did the bad thing of not putting it in my own schema. So I actually don't know where that just went to. I wonder if it went to it didn't actually go there. It probably put it in the Sequila. Get customer rentals. I'm actually not sure where that just went, but anyway, we should put schema name dot object name, whether it's a table or stored procedure or function in there. You should put yours in there, and we should do, it's always just safe to do that, to put the schema name or database name, then table, or the view or whatever object. So you don't, if there's one in a different database, that you don't use that instead by accident. Okay, so we have these tables from Sequila. This is what this query will look like. And then we have a parameter of customer ID. It's an in parameter, so it goes into the function. We use it down here for whatever we put in the statement that calls the stored procedure. So notice now it's a dynamic because I'll be able to change and run this. So I've created the stored procedure, create the stored procedure within my schema. You see the arrow now, and then I get this get customer rentals, and it even shows the parameters here. Okay. So then we could do it. This is an object, so use my schema and then customer get rentals. It says Sequila. Oops, that's why. I accidentally put that on there. So if you create a procedure, you can also drop. You can drop any database object. So I made a mistake, so I'll just go ahead and drop it. Get customer rentals. It actually didn't like that. Okay. Get customer rentals. Or I could drop it this way. Okay. So I went over to the Explorer and dropped it. Didn't like that piece of code. So let's go ahead and recreate this. It's just like a view that you can drop. Basically, a procedure is just code that you're storing until you execute it in the same way a view is. Go ahead and run all this. We did a call J Bergman get customer rentals. We give it that customer ID of 5, and then it gives you all of the rentals related to the customer who had customer ID is equal to 5. So you say, now what if we do customer rentals 3? Gives you a different result, those for customer 3. Customer ID as customer, or customer as customer ID 3. So now it's a dynamic piece of code. I'm curious, it does not have the exec statement in here. So in MySQL, you use the call statement for stored procedure. In Microsoft SQL Server, it's exec. Okay. Like some of those movie titles, The Raging Airplane. All right, we are right at the end of this, so we're just gonna keep going through it. Functions. So functions are routines. So they have a number of steps that returns a single value given the function's parameters. So very similar to a stored procedure, but now you're returning a certain data type. And there are a number of options that go along with it. So deterministic is, let's always use that. That's like it runs the same way on the data every single time. It always produces the same result versus non-deterministic. And that's not a very good explanation. I can get a better one for you. But then you can do some other options, contain SQL, no SQL, read SQL data, or modify SQL data that determines the behavior of the function. And I'll get everyone a link that gets you more information to those. I'm not very good at explaining those, but you do have a beginning and end to it where you declare your variables. And for this function, it's like you do that inside of the begin statement. And then you have your logic in here with SQL statements and control structures and then you have this return statement. So it's like a function in programming that returns a value. If you do, if you're familiar with programming and programming languages, you could have a function like a stored procedure that just does an action, or you can have a function that returns a value. So maybe it's like a mathematical function that you can put a couple values in and it returns a value. So that's what a function would be. So the example here is a calculate the rental ID, rental of a given, or calculate the number of days of a given rental is what I meant to say there, using the rental ID as a parameter. Calculate the rental of a given rental. I wrote that kind of funny, but what this is supposed to do is return the number of days of a given rental. So get the rental ID, and it's a difference between the return date and the rental date in days. So you give it a specific rental ID, give you the number of days it's been rented. And then you could use it within your regular SQL. So you could do a rental ID and then get your rental duration from Sequila.rental. So let's go ahead and give this a try. So now you have like a column that you're working with. So we'll go through each one of these rental IDs and tell you the rental durations is what this will do. So you're applying it to a whole column, where you're applying it to each rental ID and getting that. So this is actually a scalar function, because you're going rental ID by rental ID, then calculating those differences and returning the values. So you're not a summary function. All right, and go ahead and run this. Get rental duration. Okay. So calculates the rental duration in days. You can run this the same way. So you see that it returns an integer, deterministic. So this will be, get rental duration, and this will be number of days. Function returns an integer. And you declare that duration as an integer. And then you select the date difference into that value from Sequila.rental. Where rental.rental ID is equal to Sequila dot rental ID. Okay, let's go ahead, create that. And then you could use it in a regular query. It says world.rental does not exist. So I must have missed it. Something up here. I wonder if these are actually all being put in the world. If these are all being put in the world database. I'll have to check that out. So I forgot to do that there. Let's see if these have been going into the world database. It looks like they have, because there's the get rental duration. That's what will happen if you don't put your schema name on it. It'll be whatever the active database is. It'll start putting those in there. And then get customer rental. So whenever I don't do that, it has been putting it in the world database. So you won't have access to do that, but that's why I don't give everyone access to administrate the whole, or have administrator access to entire database. All right, so you have the create functions and then your usage. So let's run this again. Should create this in my schema. Ooh, did I forget something again? I don't think so. Run this. Function get rental duration already exists. You have to also, one thing, you have to reference that function by your schema name and function name. So it's actually an object that exists inside of the database that you reference, and then you have your value there. So since this is a scalar function, I don't have to do a group by from Sequila. See, even the best, even the best wrestle it. Nah, I can't call myself the best, but even me with experience, it's easy to forget things in SQL query or little things. I just know all of it because I've worked with it so much. Unknown column Sequila dot rental ID because of this. Dot rental from Sequila where Sequila dot rental ID is equal to this parameter rental ID. So I have to drop the old one. I'm going to write an alias here. Give that a table A. Makes it a little easier for my brain. So this is Sequila dot rental ID. Rental ID. So I'm giving this table an alias A. We saw how we could do that during joins. And then we do the field from that table is equal to that parameter rental ID that you equal. So what this will do, this will get you the rental ID that you were using in this query. It'll look it up in the rental table and it'll get the date difference for that record. Okay. Think this should work. Sometimes I don't know until I actually run it though. Okay. So I'm a big fan of using aliases to be able to keep things straight and what table fields are coming from. Function get rental duration already exists. Go ahead and drop that. You can even get the SQL if you want. That's what it'd be drop function. So if you're ever in a hurry, you could either drop function from the navigator, or you can send it to a SQL query. Or if you're doing that, if you're dropping it, you can review the SQL first. Okay. So created that function. Let's give this another try. Oh, finally. All right. So now you see it works as it intended. So it goes through the Sequila rental table for each ID. It uses this function that you created inside of your schema because you tell it that and to do the get rental duration. It'll go get the rental ID from the Sequila.rental table, passes each one of these into the function, and then does that lookup on the table, that date difference lookup to get this value. I said the most common times I use this is if I have some function that doesn't exist within the relational database, a complicated function, and I need to do it at the database level. Some complicated, usually like a complicated statistical function, complicated calculation on like a column. Create a column function to do it. sometimes, yeah, calculating outliers or statistical scores, something like that. But in theory, any one of them you could do, either a scalar or an aggregate function. Yeah. So last is triggers. I'm not going to cover this because I don't want to edit, don't want to do anything to these tables. But the triggers are database objects, and they're not routines. They are multiple steps that automatically executes in response to an insert, update, or delete option. So you have one query in here. It'll be like an update, insert, or delete. And then you could create the trigger after an insert on a table. So you give the trigger an alias, and it'd be like during insert or after insert. And then the operation is on each row where this applies. You can begin your update logic on it. So what this does is updates the counts in a different table based on what's being inserted into the rental table. So let's see, update. So yes. So after a new record is being inserted on the rental table, there's this table called film stats. After that happens, they calculate the number of rentals that happened on the various film IDs. And they select all the film IDs to do that. So they recalculate all the rental counts after this happens and then update that table. So they aren't necessarily updating just another field in that table. Once one value is updated or inserted or even possibly deleted, they're taking a value in one table that's updating and updating a value in another table. And they actually do that with the set logic. Well, that's how you'd usually update a field. So they take the existing rental count and then they do a rental count plus one because they're figuring that with the new record, that ID, that film with that ID has just increased by one. And they do it with this new keyword, like it's a new record. So there's a lot that goes into the triggers. I barely ever use them, but it's good to know if you're looking through code, how I talk about in the class, how understanding how data is processed, goes through processes and updated in the tables. You may come to a point you're like, well, where does this rental count come from? And then you say, by reading through this trigger example, you could say it comes on the insert of every new rental. It increases the rental count. You start to know how the data is generated, which helps you as an analyst. You don't write too many of these. The example is to prevent customer orders to not exceed a customer's credit limit. So I didn't actually have that example in here. That was the old example. But you could also do certain things like have some logic to check to make sure something's not over a customer's credit limit. And then if it does, you could throw an error if the updated record or the new record is above their credit limit, if the total's above their credit limit. All right. Just covered a lot in a short amount of time, but wanted to get to the other things that we want to cover tonight. But for review tonight, temporary tables and common expressions, use those fairly frequently. as a data analyst, especially with multi-step processes. You have standard versus procedural SQL. So 6 out of the 7 lectures, you learned all about standard SQL. You learned about procedural SQL tonight. Definitely won't be an expert over it just from that, but you'll have some familiarity and some examples. There's some very light examples in the last homework that I believe that I took creating a function out, but I like the idea of creating a stored procedure to do a calculation and then returning it. So you will create one of those. And then for these procedural SQL, we learned the structure, syntax, how you declare variables, even handle errors. And then the different types of routines. So stored procedures and functions are the routines, and then triggers are its own type of logic. So that's where I usually had concluded them in the past, but we'll have one more lecture here. So it's not adios for us yet. But I do of course, always appreciate everyone in class. So that's it for lecture tonight. We covered that pretty quickly. Did anybody have questions over tonight's material? Potentially how you would use it? Matt, I saw your camera flash on. And if you get to the stage either. Maybe not. That's something, these are things that you really use more practice with. You could probably teach a mini course in it, really. Just that part, but that's useful as a data analyst to introduce them in this class in favor of a couple of lectures that I had before. On the final exam, what I do is add feedback for the class. So if anybody feels like it'd be valuable to take those like first 6 and expand those into 7 and have this as its own like separate lecture, or one that we covered just briefly, let me know. Always willing to adjust the class. This one is probably more so than things I did in the past, like enterprise data and ETL tools and stuff like that, which I'll briefly cover on Tuesday as we work on our projects. I'll go through those fast and just give those to everybody as reference. But if we're good with that lecture, I'll give everyone like a 10-minute break, and then we can come back and I'll sign the final exam, the last homework, and then start answering any questions about homeworks or things that you're stuck on or anything else. Sound good?
Sounds like a plan.
Okay, deal. I'm going to take a couple-minute break here to grab a coffee and caffeinate. It's that time of night. But I'll be back in a few minutes, and we'll go through the rest of it. All right, back in a few. Thanks, everyone.